Hello and welcome to symbolic logic, also known as formal logic. Symbolic logic is distinct from critical thinking as a philosophy course insofar as symbolic logic focuses on a deep dive into one mode of argumentation. However, in this particular introduction, I want to take a general view of argumentation so that you have a sense of what it is that we'll be doing, in part by a contrast to the study of a mode of argumentation that we will not be studying, but that you would study in a critical thinking course. In addition, we'll touch on some important concepts that you will be mastering sooner rather than later. However, if you get stuck on any one of these concepts, by virtue of moving forward in your study, it should be the case that not only do you gain some familiarity with them, but also some facility. Now, before moving forward, I do want to point out that it's typically the case with an introduction like this that it's hard for us to get a sense of what it is that is being discussed because we don't yet have experience with it. That said, I hope that the introduction provides you with some sort of conceptual markers so that when you do when you embark on the detailed study, you think to yourself, okay, I remember we talked about this early on, and now because of this big picture that was introduced, I have a way of placing what I'm studying in a larger context. In academic philosophy, logic is defined as the branch of philosophy concerned with the science of correct reasoning. And the science of correct reasoning then involves validity, soundness, and completeness. Now, as I just mentioned a moment ago, it is probably the case that these concepts, these terms, don't really have any meaning. Even when they're defined, they don't make much sense. And that's okay. But if you're familiar with them, when it does come time to focus specifically on validity and soundness, and probably also to a lesser extent completeness, you'll say, I understand what's going on. But right now, we're just sort of laying out some of the conceptual territory so that you get the start of a map of the system that we'll be studying. So first off, it might be helpful to say when we're talking about logic as the science of correct reasoning, that we're talking about arguing. So we want to define an argument, and we also want to say that contrary to common thought or thinking or beliefs about argumentation or argument, it's not the case that we're talking about just mere dispute, right? Arguments occur all over the place in our daily lives, and this fact tells us something about the nature of argumentation. Not only is it the case that argument is not just disagreement or dispute, it's also the case that when we enlist argumentation, or we enlist an argument, or we mount an argument, either knowing or not knowing the rules of good argumentation. So let's talk a little bit about what an argument is, what constitutes an argument, and then how we can understand an argument in terms of validity and soundness, where validity for our purposes is going to be the most important concept. We'll also talk about validity synonymously with the expression logical correctness or logical consequence. So an argument is a set of statements, one of which is supported by the other or others. So we'll say more about an argument in a moment, but let's start with looking at what constitutes an argument, and that is, as I mentioned, a set of statements. A statement is a specific type of sentence. That is, it is a sentence that has a truth value. It's a sentence that is true or false. For example, here's a declarative sentence that has a truth value. Stuart Stuffy Chunks Thompson, Joseph K. Joe Doggy Dogovich, and Horatio H. Kane Bobby are best friends. So you can see on the left The creamy dog is Stewie. The dog in the middle is Joe. And the dog on the right is H. And the sentence, Stuart, Joe, and H are best friends, is true or false, depending on whether or not it is the case that they are best friends. Let's look at another sentence. Joe Doggy has spots, but Ella McPunks-a-lot Anderson doesn't. Here's a photo. Joe's on the left, Ella's on the right. Let's look at one more sentence. Aloysius Ferdinand and Bret Michaels are cats. There's Bret on the left, hanging out with Joe, and there's Al on the right. Each of these sentences could be the constituents of an argument. So when we're talking about an argument, we're talking about a collection of statements. So at least two statements, one of which is supported by the other or others. So what you'll notice as we move forward is that an argument is a set of statements that bear a relationship to each other that we're going to call an inferential relationship. In other words, the statement or statements that do the supporting are the statements that imply the supported statement. The supported statement is inferred from the supporting statements. Now, to be even more specific for the purpose of our course, the sort of support that we're going to study involves the concepts validity and soundness, although you'll see as we go forward that our real focus is on validity, precisely because soundness is typically very difficult to determine. Okay, so what I'm going to do now is pull together a couple of ideas. We're going to, as I mentioned before, study what it means for reasoning to be correct. In other words, we're going to study arguments that are or are not valid. Another way to put this is we're going to study reasoning that is logically correct, or we're going to study reasoning which involves sentences that are true or false, arranged in such a way that one of them is or is not supported by the other or others. Another way to put this is these sentences are arranged in such a way that one of them is or is not the logical consequence of the other or others. Now, what we're going to focus on is the argument system known as deduction. Now, there are different versions of the system. The version of the system that we're going to study is presented in the textbook Language, Proof, and Logic. Okay, so deduction is a mode of argumentation, and in a deductive argument, the supporting statements are claimed to guarantee the supported statement. In other words, the supporting statements are said to force the supported statement or support the supported statement in such a way that that statement is guaranteed. All right, let's look at a couple of examples. And it will be helpful, I think, if you bear in mind that a deductive argument can be thought of in terms of an argument that's non-experiential. In other words, when we reason our way from one statement to another or from a set of statements to another, we don't use experience to guide us. Instead, we're guided by the structure of the reasoning itself. We are guided by the understanding of the terms in the argument. Okay, so the first one comes from Philosophy in the Flesh from thinkers George Lakoff and Mark Johnson. If the essence of all things were coldness and wetness, fire would not exist. Since fire does exist, the essence of all things that is real cannot be water. And the second example from a novel, The Blood Spilt, goes as follows. And it was as if Bertel had already forgotten what she was really like. When he spoke about her nowadays, there was warmth in his voice. She had a big heart, he sighed. She had a greater talent as a pastor than I myself, he maintained generously. That implied that she had a greater talent as a pastor than Stefan, since Bertel was a better pastor than Stefan. Let's go ahead and break these two arguments up so that we can look at how each functions. More specifically, let's try to see the structure of each argument. And what I'm going to do for the second argument is look exclusively at the greater talent as a pastor relationship between she, we'll give her a name, a character in the book, and Bertel and Stefan. Okay, so what I've done here is I've taken as much of the content out as possible so that the form of the argument is revealed. Now, the last sentence in the original argument, that is, the essence of all that is real cannot be water, is a sentence that contains the word water. I take the first sentence, if the essence of all things were, all real things, were coldness and wetness, fire could not exist. I take the words coldness and wetness to be synonymous with water in that last sentence. So what I've done is I've replaced cold and wet and water with W, and then fire is replaced with F. We still have the, if you will, the joints of each of the sentences. Notice that we have if W, then not F. And then the sentence, fire could not exist, which is the last part of the first grammatical sentence, is rejected in the first part of the second grammatical sentence. So we have a grammatical sentence, if the essence of all things were coldness and wetness, fire could not exist. That grammatical sentence we can break down into two. The essence of all real things is cold and wet, and fire could not exist. Now we can further break down those sentences, but let's for the moment just focus on the sort of the overall structure here. Notice that the sentence fire could not exist is rejected in the first part of the second grammatical sentence. Fire does exist. So we take the second grammatical sentence, since fire does exist, the essence of all that is real cannot be water, and we see that even though we have a single grammatical sentence in that second sentence, it's actually broken up into a supporting statement, fire does exist, and the inference, the essence of all that is real cannot be water. So the breakdown reads as follows: if W, then not F, but it is F, so it's not W. Here's another example in the same form. If today is Monday, then it is not Tuesday. Since today is Tuesday, it is not Monday. And here's the form. If M, then not T, it is T, so it's not M. Now, we don't need to know whether or not today is actually Monday or Tuesday. It's the form of the argument that guarantees the inference. Now, we'll see that not every argument of the deductive variety has this sort of, or reflects, I should say, this sort of guarantee. But I hope that this gives you the basic idea of what sort of argument we're talking about. Here's the second argument with she, whoever she is in this novel, and Bertel and Stefan. So recall that we have the reasoning that I'm focusing on, starting with she had a greater talent. So the reasoning goes like this. She had a greater talent as a pastor than I myself, he maintained generously. That implied that she had a greater talent as a pastor than Stefan, since Bertel was a better pastor than Stefan. Now, I'm going to use greater than and better than as synonymous terms. Technically, they're not. And so when we're, reasoning carefully, we want to make sure that all of our terms are in order. But to get us started, you get the idea of what the author is after. So I've used a greater than symbol to reflect the relationship between she, Bertel, and Stefan. So she is greater than Bertel, Bertel is greater than Stefan, so she is greater than Stefan. Now notice too that in each of the examples that I've presented in terms of a form, I've taken them out of the prose style and put them in an argument form style. We'll see that this is called standard form. But you notice that the supporting statements appear above a line and the inferred statement or the supported statement appears below the line. And that's just standard practice in logic, whether we're studying deductive logic or inductive logic, if we're doing a critical thinking course, for example. So we won't study induction, but I mention induction just to give you an idea of the scope of logic and to help us better understand what we're going to study by way of a contrast to induction. So inductive arguments are experiential. When we reason inductively, we consult experience to determine whether or not the argument is strong or weak. Here's an example. The thief must have had a key to the house. After all, no windows were broken and all the doors were locked. Besides, the chimney is too narrow for anyone to slide down. I don't see any other way to get inside. The inference is drawn based on observation, not on a conceptual relationship between terms and not on a structural relationship between the supporting and supported statements. Now, I mentioned earlier that the concept of validity, also known as logical correctness and logical consequence, is crucial to our study. It's also, however, the most difficult to grasp. So getting familiar with it and practicing with it is going to be important to ultimately mastering it. So what we say when we say that one statement is a logical consequence of others or another is we're saying that the inference that's drawn is an inference that has to be on the assumption that our evidence is correct. And what I mean by that is based on the organization of the sentences into a certain structure, based on certain relationships, conceptual relationships, we yield a conclusion or we yield the inference. So let's say a little bit now about soundness. I mentioned at the outset that we won't spend much time talking about soundness, and that's because determining whether or not sentences are in fact true is not always possible. So what I mean by that is this. There are going to be ways of thinking about truth in the deductive system that we're studying. And some of those ways of thinking about truth don't require any sort of verification by way of how the world is. So while it certainly is the case that plenty of sentences in arguments, in deductive arguments, can be verified by way of how the world is, a situation, for example, a state of affairs. That's not the exclusive manner by which truth is determined. So more on that later, but what I'm hoping is that by touching a little bit on soundness here, you will thereby get a better basic understanding of what is meant by validity. Okay, so you can certainly think about whether or not you believe that the sentences in each of these arguments are true. But I'm going to point out that whether or not the sentences in each of these arguments are true that is not what makes the argument valid. Okay, so first, the definition of soundness. A sound argument is a valid argument. So a requirement for soundness is validity. On top of that, the sound argument's the sound argument's premises, that is the evidence, the sentences that are used to support the inference, are also actually true. So let's take a look at the first example. If Barack Obama is president of the United States, then the year is 2013. It is not the case that the year is 2013, so it is not the case that Barack Obama is president of the United States. Now, you might be a little bit put off by the first sentence. You might think that the first sentence is false. Let me just tell you that it is not. And I'm about to give you an example that I hope will kind of pump your intuition on what I've just said. We'll study in propositional logic. Specifically, we'll study the Boolean system of generating true and false statements by way of connectives. That sentences of the type you see in this first example, if Barack Obama is president of the United States and the year is 2013, that when each part is false, the sentence as a whole is true. In other words, the if-then sentence is true when each part of that sentence is false. So it's false that Barack Obama is president of the United States. It's false that the year is 2013. But in the system that we're going to learn, the sentence is true. So here is an example to try and help pump that intuition. If California is in England, then California is part of the UK. It's true that if California is in England, it is part of the United Kingdom. The fact that each part of the sentence is false does not make the sentence as a whole false. I know, again, that might be counterintuitive, but I hope that providing this particular content will help you see that the sentence as a whole is true. Okay, let's go back, though, because what we're after here is understanding that a sound argument is valid and the premises are actually true. So the first two sentences in each example under the first bullet point are true. In addition, because those sentences are true and the argument is valid, the argument is known as being sound, or it's classified or satisfies the requirements for soundness. Let's take a look now at the second example. The moon is made of blue cheese or green cheese. It's not made of blue cheese, so it's made of green cheese. Here we have again a valid argument, but it's not sound. That's because at least one of the first two sentences is false. And then lastly, all invalid arguments are unsound. Now in this intro, I've focused on what constitutes a valid argument. An invalid argument is one in which the evidence, the supporting statements, the premises do not guarantee the inference. So let's take a look at the example. Some dogs are athletic. Herman is athletic, so Herman is a dog. The problem is that we don't know, by way of the structure of this argument, that the dog class and the athletic class relate to each other in such a way that Herman has to be a dog on the basis of his being athletic. So the class of athletic things conceivably contain things other than dogs. All right, so all of this, let's go back and just quickly review. All of this that I've just talked about should give us some idea of what we're looking for when we're looking for a logically correct argument that has quote-unquote good content. right? So if we have a sound argument, we have a logically correct argument, the whose content in the way of the evidence is true. The sentences that give us the evidence, that do the supporting, are actually true. This next set of examples should be a bit easier for you to work through, and it should be a bit easier, and it should be a bit easier for you to see the difference between a valid argument that is sound and one that is unsound. I also hope that the last example will help you recognize what makes an argument invalid. So again, our first argument is sound. That is, the argument is valid and its premises are true. San Francisco is to the north of Los Angeles. Los Angeles is to the north of San Diego. Consequently, San Francisco is to the north of San Diego. This relational argument is one that you could just map out. So let's say you didn't know whether or not it's true that San Francisco is to the north of Los Angeles and so forth. You could diagram the argument. Put write the words San Francisco, and below that write Los Angeles, and then below Los Angeles write San Diego, and you'll see that according to a sort of standard compass, San Francisco, as written, is to the north of San Diego. Now, the sentences are also, in fact, true. It is the case that San Francisco is to the north of Los Angeles. Los Angeles is to the north of San Diego. So the argument is valid. The evidence, the supporting statements, the premises are true. The argument is therefore sound. Remember, though, that not all valid arguments are sound. Let's take a look at the second example. New York is to the east of Paris, France. Paris, France is to the east of Berlin, Germany. So, New York is to the east of Berlin, Germany. The argument is valid if you map it out. Let's say you write on the horizontal. You would have New York to the right of Paris, and Paris to the right of Berlin, right? So even though structurally the argument works, the problem is that the evidence, the first two sentences in this case, doesn't bear out. In other words, the first two sentences are false. Lastly, all invalid arguments are unsound. And remember what an invalid argument is. An invalid argument is an argument whose evidence or supporting statements do not guarantee that the inference is correct, that the statement that is supported is true. So we have the following. Chicago is north of Miami. Chicago is north of Atlanta. So Miami is north of Atlanta. So it's true that Chicago is north of Miami. It's true that Chicago is north of Atlanta, but it does not follow from this, and the concluding sentence is also not true, does not follow from this that Miami is to the north of Atlanta. Okay, so I've been using the language of truth and falsity throughout this overview, and I just want to start to wrap up by saying a little bit about truth. So when we study logic, we talk about truth in terms of being a property of statements. So we have sentences that are either true or false. So when we're talking about a theory of truth, we're talking about understanding truth in terms of statements, right? So truth belongs, if you will, to statements. Another way that we talk about truth and falsity in connection with statements is to talk about a statement's having a truth value, which is to say a statement is either true or false. So we're going to begin our course by talking about statements, In the textbook that we're using, Language, Proof, and Logic, the words statement and sentence are used interchangeably. And it's also the case that we will learn a specific notation, a logical notation, for our system of logic. So depending on which textbook you pick up, you can get either very similar or significantly different notation. But at the end of the day, the notation that we use, like any language, is artificial, right? So, think about it this way. The Cyrillic-based languages versus, let's say, character-based languages are different notations for expressing ideas. So in logic, we're going to use a notation that is specific to this version of the deductive system that we're going to study. So let me say just a tiny bit about that. We are focusing on first order logic, which is concerned with reasoning involving objects. And in order to make clear the structure, the logical structure of the sentences that we'll be using in argumentation, we learn a notation that will help to reveal that structure. All right, I hope that this tutorial has been helpful as an overview. Again, I want to remind you that this overview covers a ton of ground. It's like it doesn't cover everything that we're doing in the semester, but it covers a lot of concepts and some skills that we will be developing over weeks. So the idea here is just to have you begin to be familiarized with the concepts that we'll be using.